In this video, we'll be going over how to derive the law of sine as well as the law of cosine. Well, starting off, the law of sine looks something like this, or it could also look something like this. You can see that they are each the reciprocal of each other. For example, sine of a over lowercase a is the reciprocal of lowercase a over sine of a. Well, you can see that there's a capital letter on top and a lowercase at the bottom. Or, in this scenario, there's a lowercase at the top and an uppercase at the bottom. The uppercase represents an angle, whereas the lowercase represents the length of a segment or side. So that should clear up some confusion that some have had. Then we can look at the law of cosine. Well, the law of cosine, there are three different laws, each depending on what type of side length or segment you're given, as well as the angle. Now, what we can do is we can go ahead and derive the law of sine. Well, here are some steps. It's very simple. I didn't get to list all the steps, but as we go on, you'll definitely get to see what the process is. So the first step is to separate the triangles, as well as label the angles. So let's go ahead and look at an example of a triangle where we are going to derive the law of sine from. This is a triangle where we're going to derive the law of sine. So let's see. Well, sine, as we know, is opposite over hypotenuse. And there are two triangles here. Let's just say this is triangle 1 and this is triangle 2. Well, we want to find the sine of each triangle because our goal is to find h when deriving the law of sine. Well, to find h, we can use sine because let's just say we take sine of b, and remember it's uppercase, meaning that it's an angle and we can't take the sine of it. So sine of b, and we said sine is opposite over hypotenuse. Opposite of this angle is h, so our numerator is going to be h, and the hypotenuse is this the longest side, which is a, so our sine of b is h over a. Now that we have found the sine of triangle 2 of the angle b, we should look at the sine for angle a in triangle 1. Again, sine is opposite over hypotenuse, and opposite of a is h, and the hypotenuse, the longest side, is b. So we have sine of uppercase a equals opposite, which we said is h, over our hypotenuse, which is b. So we have sine of a equals h over b. Well, we want to try to make both these equations equal to each other. And we can see they both have a common value of h. We need to think about how we can set both equations equal to h. In order to set both sine of b and sine of a equal to h, we need to multiply by the denominator on both sides. Well, let's see where we have space. Well, if we multiply by b, we multiply by b, so the b is eliminated on the right side, and then we would have a b on the left side. So this would become b sine of a equals h. Then we would have to multiply by a is eliminated on the right. We add a as a coefficient of sine of b to the left, which leaves us with a sine of b equals h. So if two things equal the same thing, that just means these two equations equal each other. So let's go back to our main area and let's start writing. So we have a sine of b equals b sine of a. Now, what we can do is, remember, our sine looks something like this. So, what we can do is, we already see that we already have a sine of b and a sine of a. So, we can see that in this top area, we have sine of a equals sine of b in the numerators. So, let's try to get to that. Well, what we can do is divide both sides by a, get rid of this coefficient. So you have sine of b equals b sine of a over a. Well, looking pretty similar to this right here. We have sine of a over a. Well, we still have a b coefficient remaining. So we can divide both sides by b, which would eliminate b, which leaves us with sine of b over b equals sine of a over a. And guess what? That is the first part of the first law of sine, where we have sine of a over a equals sine of b over b, and we have just derived the law of sine. Now let's go ahead and do cosine. Now we're going to derive the law of cosine. As we can see, the first step to derive the law of cosine is to solve for triangle 1, then solve for triangle 2, set equal to h squared, FOIL, simplify, isolate a squared, find the value of x, and then substitute in the value of x. Alright, so first let's look at our triangle. Again, we're going to separate triangles. Now let's call this triangle 1 and this triangle 2. And we're going to start out with the Pythagorean Theorem. So the Pythagorean Theorem, as we know, is a squared plus b squared equals c squared. Then, what we're going to do is substitute in values. So let's start out with triangle 1. This is the separating triangle part, triangle 1. So in triangle 1, we have this. Oh, let's just highlight it or outline it in black. So this is triangle 1. And let's highlight the other one in blue or teal. This is triangle 2. So now that we are looking at triangle 1, we can see that we have an x value here. So this is our base. This is equal to a in terms of Pythagorean theorem. This is b and this is c. So we have x squared, let's go to white, x squared plus our b value h squared equals c squared, which was b squared. Now what we're going to do is, since we have it equal to b squared, let's go back to our steps. We want to now set it to h squared. So we're going to subtract x squared from both sides, which leaves us with h squared equals b squared minus x squared. So now that we have h squared equals b squared minus x squared, we're then going to go to triangle 2. So this is all triangle 1. Now let's go ahead and do triangle number 2. So triangle 2, we're going to do the same. A squared plus b squared equals c squared, which is Pythagorean theorem. So now we use teal, so let's go back and use that same color. Okay, so we have an a squared value of c minus x, a b squared value of b value of h, and a c value of a. So it would be, let's do the c minus x squared plus our b value, which was h squared equals our a value, our c value, which was a. So this is our equation, and again we want to set it equal to h squared. So we're going to subtract this on both sides. So then we have h squared equals a minus c minus x squared. Now the next step is to FOIL. So the only one that we have to FOIL is this right here. So we have c minus x squared, meaning it's getting multiplied by itself. So we have c minus x times c minus x, which is c squared. So we have this times this, then this times this. So we have c squared, okay, we have c squared minus cx minus cx minus, plus x squared. Now we combine, so we get c squared minus 2cx, because these combine, plus x squared. And this is equal to this parenthesis right here, or right here. So now that we have this, let us simplify it down, or expand it out, I should say. So we have h squared equals a minus the value we just found right here. So we have so we have h squared equals a minus c squared minus 2cx plus x squared. But remember, this was in parentheses, so we have to distribute the negative. So we get h squared equals a minus c squared plus 2cx minus x squared, because you're distributing this negative, meaning we're multiplying all the terms by -1. So now that we have h squared equals a minus c squared plus 2cx minus x squared, we have set both triangle 1 and triangle 2 equal to h squared. Now we need to simplify, which we have done. But since they both equal h squared, we can now set them equal to each other. So let's do that down here. So let's use white. So now we have b squared minus x squared equals a minus c squared plus 2cx minus x squared. Well, we got this from triangle 1, which is up here. And then we got this from triangle 2 after foiling and then simplifying down here. Since they're both equal to h squared, they're both equal to each other. So now what we can do is we want to isolate a squared. Now we want to isolate a squared. I forgot the squared in the previous parts. So we're going to isolate a squared. And in order to do that, we're going to be adding these terms to the other side or moving them to the other side. So again, we're isolating a squared on the right side. So we have a squared equals, and then plus c squared minus 2cx plus x squared on the left side. So we have b squared minus x squared plus c squared minus 2cx. Let's move this a squared to the right a little more. Minus 2cx plus x squared equals a squared. And again, we can simplify this because negative x squared plus x squared is just 0. So we are left with b squared plus c squared minus 2cx equals a squared. And now we need to figure out what x is. Well, if we look at our triangles, we can see that our sine of our a value was h over b. And then the cosine of our a value was x over b. Well, what we can do is, since we want to isolate x and solve for it, why don't we do cosine of a? So let's just write that up out here. So we have cosine of our a angle, and cosine is equal to adjacent over hypotenuse. Adjacent to this a is x, so we have x over our hypotenuse, which is b. And again, we want to isolate x. So in order to isolate x, what we want to do is to get b up here. So we get b cosine of a equals x. Now we're going to substitute that value of x in as our last step says. So that was simple. You might be asking why we didn't use this triangle. Well, here we have x by itself, but here we have c minus x. It would have been a little more complicated. So I just went ahead and did triangle 1. So now that we have x equals b cosine of a, let's go down here and input that value. So let's rewrite it down here. So we have b squared plus c squared minus 2c times b cosine of a equals a squared. Well, I think we may be done. Let's go ahead and check it. So we have this base form up here, where a squared equals b squared plus c squared minus 2bc cosine of a. Well, let's bring this guy down. So now we have 2bc cosine a. And remember, we can just rearrange it in order to make it look like this. So we have a squared, right? We have a squared equals b squared plus c squared minus 2bc. This is the base form. So we have our b squared right here, b squared, and we're adding c squared like in the base. Okay, so we're good so far. Minus 2bc. Well, you can see that we have 2cb. Well, we can rearrange that, no problem. We're just multiplying by each other, so we can just move it around. So we have minus 2b times c. And c, it's multiplying by cosine of a. So multiplying by cosine of a. And again, it all equals a squared. So we have successfully derived the cosine, or the law of cosine, using this triangle. I hope this video helped, and if you believe it did, please consider to like and subscribe. I'd greatly appreciate it. And remember to turn on the bell icon for future video recommendations. Thank you.